Good afternoon. My name is Vitaly Khusidman, and I am the CEO of G3C Technologies Corporation, G3CT, a US company developing methods and systems for converting scrap tires into reinforcing recovered carbon black. At the Recovered Carbon Black Congress in Berlin in 2019, G3CT has introduced the notion of three generations of carbon black recovery technologies, where the first generation is focusing on recovering oil out of the scrap tires, and the carbon black was a byproduct of this. Generation 2 focusing on recovering carbon black, which can be used in the industrial rubber and plastic applications. It also can, in some cases, augment virgin carbon black for carcass of tires. And generation 3 is covering the solutions which not only recover but also upgrade carbon black. Because of that upgrade, this recovered carbon black produced by generation 3 can be used not only in carcass but in all parts of the tire, including the tread. In this slide, we illustrate the notion of the phenomenon of the RCB in rubber performance shift. It means that the colloidal properties of recovered carbon black can achieve the values which would be typical for the reinforcing virgin carbon black. However, when this recovered carbon black is used to make rubber, then the actual characteristics, physical characteristic of this rubber would be similar to semi-reinforcing carbon blacks, virgin carbon blacks. This phenomenon was described in a number of publications, which are shown in this slide, reference to this shown on this slide. And the implication of this phenomenon is that end-of-life tires derived pyrolysis recovered carbon black can only replace carcass grades of virgin carbon blacks. Traditional in rubber performance prediction model, which works well for virgin carbon black, does not work for recovered carbon black. There are a number of publications where this phenomenon was attempted to be explained. For example, Peter Terhar suggests that since recovered carbon black consists of, in addition to carbon blacks built in the tires, it consists of the inorganic contaminations and also chemical effects, mostly caused for carbonaceous residue coke. The result of the same of the materials with the same colloidal properties in case of recovered carbon black would be worse than it would be for virgin carbon black with the same colloidal properties. Another researcher, Dr. Chris Norris, suggests that in addition to surface area and structure level, which are typical for the virgin carbon black prediction model for behavior in rubber, the prediction model for recovered carbon black should include other factors such as surface chemistry, cleanliness, aggregate size distribution, and composition. G3CT approach is based on the fact that the fundamental properties of the carbon black are surface area and structure level, and therefore the approach is to drastically increase the these two property values. And at the same time, other factors which also contribute to the in-rubber performance of recovered carbon black are either addressed or not addressed by this approach. For example, decreased oily residue in PAHs also included the G3CT approach. However, it's not unique to this. Decrease of agglomerate size and sieve residue also included in G3CT approach, but not unique to this. And factors such as ENF, composition, or surface chemistry are not directly addressed by G3CT approach. So if, for example, inorganic impurities would be removed, that will further improve the results received based on just the G3CT approach for converting scrap tires. This slide demonstrates how G3C method is allowing to receive reinforcing RCB. Since the G3C method allows to receive the recovered carbon black with higher colloidal properties such as surface area and the structure, the starting point where the detrimental factors start playing their role is much higher, and therefore even after that these detrimental factors play their role, even after that the resulting material still have reinforcing qualities. While this is shown on the right side. When on the left side you could see that detrimental factors reducing the reinforcing properties of the carbon black, recovered carbon black, and when made in the rubber, they already not demonstrate the reinforcing performance. They perform as semi-reinforcing material. G3CT offers a sustainable solution to produce the entire tire. Therefore, we call it true circular economy for tires. How does patent work? G3C method uses water, vapor, gas as a reagent of chemical reactions taking place in G3C reactor. Disassociated atoms of hydrogen and oxygen are extracting atoms of carbon from carbon black primary particles aggregated in acinoform-like structures. Extracted atoms of carbon form molecules such as CnHm, CO, and CO2. As a result, carbon black primary particle reduce in size, and the acinoform composition of aggregates become more complex, which results in upgrading the carbon black component of the material, of course at the expense of decreased yield. And the level of decrease depends on the desired grade of the material. The higher the grade, the less the yield. How G3C method differentiates itself from traditional pyrolysis? G3C method recovers and upgrades carbon black, versus traditional pyrolysis just recovers carbon black built in tires. G3C method produces a large spectrum of recovered carbon black products based on the changing parameters of the process, versus only a few grades produced by traditional pyrolysis. G3C RCB grades augment or replace reinforcing VCB grades, while traditional pyrolysis at best augments semi-reinforcing VCB grades. G3CT solution represented dramatic improvement for recycling of carbon black built-in tires. No other existing technology is known to produce recovered carbon black matching in rubber performance of G3C RCB. To prove the fact that G3C process reducing the primary particle size, we have conducted the experiment where the same feedstock was processed using traditional pyrolysis and then was separately processed by the G3C process. And in this case, the average primary particle size, as you could see on that PSD, particle size distribution, reduced from 66 nanometers to 36.9 nanometers. And external surface area increased from 48 square meter per gram to 124 square meter per gram. G3CT has commissioned the testing of some of G3C grades at the ACE lab in Ohio, where the several virgin carbon black grades, including N339 and N330, were compared to some of the provided G3C grades. And the results shown that the physical characteristic are such that G3C1 has comparable in rubber physical properties to N339, and G3C2 had comparable physical properties to N330. You could see the values of the tensile strength here, and modules and elongation, and as well as durometer hardness. On the right side of this slide, you see this graph for the temperature sweep 10 delta. And you can see that the samples produced with the help of using the G3C RCB show similar performance to the samples produced using N339 and N330. And in some cases we could see that, for example, with lower temperature show better performance, and also it is expected that rolling resistance would be better for the material made out of G3C recovered carbon black. Another set of experiments testing were commissioned with the Akron Rubber Development Lab. This slide shows the formulations where two control samples from virgin carbon black N339 and N330 was used. Two samples of G3C RCB were used with 100% load, and one sample was used with the one formulation with the 50-50 load between the G3C RCB and virgin RCB N339. And the next slide shows that the results for the testing, this in a thread formulation. This was a thread formulation, and in thread formulation we see that the mix of 50-50 perform pretty much comparable to the N339. Therefore, we can say that the mix 50-50 mix of G3C RCB with N339 can replace the compound made of 100% of 339. This slide demonstrates the results of the experiment testing done in Akron ARDL for the body ply formulations. The control sample was N550, and on the left side you see the formulation, and on the right side you see physical results, where we see that illustrates that G3C material can replace 100% of N550 in the body ply formulation. And this slide illustrates the testing done for inner liner formulation. On the left side you see the formulation where the control sample is N660, and on the right side you see the results for the physical testing, and we see that G3C sample capable of replacing 100% of virgin carbon black in inner liner formulation. Now let's talk about systems for producing G3C RCB. There are two plant implementation models. On the left side of the slide you see one stage implementation model. In this model, the feedstock, scrap tire crumb rubber, is loaded into G3C system which is producing the char, which then milled and pelletized and become the product recovered carbon black. On the right side, you see two-stage model or RCB valorization model, and this is preferred model for us. In this model, feedstock is fed in the pyrolysis system. Pyrolysis system actually does what this low temperature pyrolysis, what it does the best is extracting oil out of the recovered carbon black. And then after that, the solid char is fed into G3C system, and after that it's milling and pelletizing. This model can be used for new plants and also retrofit to existing pyrolysis plant where the G3 system is inserted between the pyrolysis system and milling and pelletizing part of the plant. Now there are a number of advantages of this model. First is that the oil produced by pyrolysis, low temperature pyrolysis, would be better quality than the oil produced by high temperature pyrolysis. And we have more control on oil production because we optimize the pyrolysis system for oil production. Second is that the capacity of the G3C system need to be much less than in case of the one-stage model, because that the input into the G3C system would be char, representing only 40 to 45% of the feedstock. And the third advantage is that the pyrolysis system produces some extra gas, which it does not use. So this extra gas go into G3C system by operation G3C system for heating purposes, and therefore the operational cost for G3C system is much lower due to this extra gas coming from pyrolysis. So this is our preferred model, the stage model. We have developed a new G3C unit design. This design using the same method, however, it is extremely scalable due to modular organization. One unit consists of number of parallel reactors, as you could see on the picture on the right side of the slide, and it can scale pretty much unlimitedly. Practically, we see it can scale up to 40 tons per day of pyrolysis char input, which would be equivalent to 100 tons per day of tire rubber. Due to the lack of moving parts in this new design, the lifetime of such a system is increased significantly. And this patent, this design is patented, and the patent is pending at this point. Commercialization of new design is going on right now. A pilot is being built in the Republic of Georgia, will be operational in early 2023, and commercial system is planned to be built in US and Europe with completion in 2024. As a summary, I would like to say that the recovered carbon black industry, with its reliance on traditional pyrolysis, has fundamental limitation for in-rubber performance of the recovered carbon black caused by inorganic impurities, chemical activity, and other detrimental factors. Despite colloidal properties of the best pyrolysis RCB products, reaching the values comparable to reinforcing virgin carbon blacks, in rubber performance of such recovered carbon black products can only achieve semi-reinforcing characteristics. On the other side, G3C process is capable to produce recovered carbon black comparable to reinforcing virgin carbon black through mitigation of detrimental factor by drastically increasing structure level and surface area. G3C RCB can be further improved by removing inorganic impurities from it. G3C process produces RCB with low pH contents compliant with regulations. G3C technology will enable RCB industry to provide filler for all parts of tires. Two-stage implementation model makes G3CT's technology complementary to traditional pyrolysis. New patent pending design enables extreme scalability of G3C unit. And the construction of G3C pilot is in progress, and G3C commercial system is being planned. With this, I would like to thank you for your time and attention, and I am ready to answer your questions. Thank you very much.